Okay, problem 4 on the review sheet. We have a football that's thrown 45 meters and is in the air for 3.7 seconds. What is the horizontal component of the football's velocity? Well, the horizontal component is going to be the distance it traveled over the time it took, because the horizontal velocity is constant. And 45 divided by 3.7 is 12 point, I'm going to go round it to one decimal, 12.2 meters per second is the horizontal component of the velocity. That is the answer to part A. Part A. Part B. What is the time to the peak? Well, T peak equals T total divided by 2, which is 3.7 seconds divided by 2, 1.85 seconds is the time to the peak. What is the maximum height of the football? Well, we know how long it took to get to the top. We want to know D. So could we use this equation? We don't know V naught, do we? We don't know V naught. That's not going to work. How can we? No, it's not the trick question. Go to what? Oh, we got it. So this is out of order. I was going to say we're going to have to solve for something else first. So the questions are not asked in the proper order to get you to the answer. And it was suggested that we solve D first, the vertical component of velocity. The vertical component of velocity. We know this, and we know time and acceleration. So we're going to use the equation V sub F equals V naught plus AT, because that's 0. And A is actually G. So V naught is going to be the opposite of gravity times time, which is the opposite of 9.8 times 1.85. And that's got to be a negative in there. It's the opposite of that. And what does that work out to be? Something just under 18? Oh, just over 18? 18.1 or 18.2? 18.2 meters per second. All right. On the video, we're arguing about rounding in the class. It's either 18.1 or 18.2. It's a rounding problem. Roll with it. All right. So, rounding, roll with it. It was my pun and I didn't get it. What is the maximum height of the football? Now we can go back and we can use probably all three of those equations. I'm going to use the second one, which says D equals 1/2 V naught plus VF times T. Actually, can I use that equation or not? I don't know if that equation works or not. Yeah, the problem with this equation is we've got acceleration involved. My mistake. Let's go to V sub F squared equals V naught squared plus 2AD. V sub F squared is 0. I'm solving for D, so D equals the opposite of V naught squared, V naught dash Y, divided by 2G, which equals the opposite of 18.15 squared, since we couldn't decide on 18.2 or 18.1, divided by 2 times negative 9.8, and that is going to be what? What is it? 16.7 meters? 16.7, 16.8, we're talking about rounding. Don't worry about the rounding. Did equation 2 work, by the way? Oh, okay, fine. So any of the equations will work to people listening on video. What was the initial velocity of the football? Well, what they're asking us is to take the square root of v sub naught x squared plus v sub naught in the y direction squared, which is the square root of, what did we come up with the initial horizontal to be? 18.13 squared plus, no, that's the vertical. What was the horizontal? 12.2 squared. And when we square those and take the square root, what do we get? 21.8 meters per second, or something close to that based on your rounding, or lack thereof rounding. What was the angle when it left the thrower's hand? Well, if we know our trig, and we call this theta, and we call this 18.13, we call this 21.8, the inverse tangent of 21.8 over 18.13 equals theta, and that equals what? 56.1 degrees. Bruce? Oh, sorry. Very good. On the video, did you catch that mistake? This is 21.8. This is, and this is wrong. This is 18.13, and that's 12.2. Sorry, on the video, that's all messed up. Good catch by Mr. Faut. So now it's tangent, inverse tangent of 18.13 over 12.2. It probably still equals 56.1 since that's the answer. Very good. Thank you for the help. If you're confused by this video, you should come see me and talk to me about it.